Welcome to our channel where we explore the fascinating mysteries of our universe. Today, we are embarking on a thrilling journey to unravel how our own planet, Earth, came into existence. Imagine a cosmic ballet orchestrated by the laws of physics and gravity, set on the grand stage of the universe. This dance of particles, gas, and dust, spanning billions of years, led to the formation of everything we see around us. The mountains, the oceans, the air we breathe, and even you and me. Isn't it fascinating that we are all made of stardust? Understanding the origins of Earth is not just about satisfying our curiosity, it also helps us appreciate our place in the cosmos and the delicate balance that sustains life. So, are you ready to venture into the past, to the very beginning of our world? Fasten your seatbelts as we travel billions of years back in time to witness the birth of our home planet. Our story begins in the vast expanse of space, within a massive molecular cloud. Picture a colossal swirling mass of dust and gas, spanning light years across, a nursery for stars and planets. In this celestial cradle, the stage was set for the formation of our solar system. Gravity, the great sculptor of the cosmos, began to weave its magic. As pockets of this molecular cloud started to collapse under their own weight, a process known as gravitational collapse was set into motion. This collapse, triggered by a disturbance such as the shock wave from a nearby supernova, transformed the molecular cloud into a dense, spinning globule of gas and dust. But what does this have to do with the formation of Earth, you ask? Well, Earth's story is intrinsically tied to the birth of our solar system, and it all started here, in this spinning globule of gas and dust. This was the raw material, the primordial soup, from which our planet would eventually form. As gravity continued to compress this globule, the center grew denser and hotter, setting the stage for the birth of a star, our Sun. Around this nascent star, the leftover gas and dust swirled, forming a flat spinning disk. This was no ordinary disk though. This was a protoplanetary disk, a cosmic carousel where the seeds of planets were sown. In this disk, countless particles of dust and gas jostled, collided, and clumped together. The dance of creation had begun. Over time, these clumps grew larger and larger, forming planetesimals, the building blocks of planets. From this cosmic dance of particles, the protostar and a swirling disk of material known as the protoplanetary disk began to emerge. This was the birthplace of our solar system, the cradle in which Earth and its planetary siblings were nurtured, a testament to the power and beauty of cosmic evolution. In the heart of this spinning disk, a remarkable transformation was taking place. This was not an ordinary whirl of dust and gas, it was a protoplanetary disk, a bustling cosmic nursery. The protostar at the center was just beginning to flex its gravitational muscles, pulling the surrounding matter into a flat spinning disk. This disk, swirling around the protostar, was a chaotic mix of gas and dust particles. But within this chaos, a beautiful dance was beginning to unfold. The particles in their ceaseless movement began to collide with each other. These weren't violent clashes, but rather more of a cosmic ballet, where particles gently bumped into each other and stuck together. This process, known as accretion, was the first step in the creation of something much larger. Now imagine this dance continuing for thousands of years. Tiny dust particles growing into pebbles, pebbles into rocks, and rocks into mountain-sized bodies. These large bodies, now more like mini-planets, are what we call planetesimals. These planetesimals weren't just lifeless rocks floating in space. They were dynamic entities, constantly interacting with their environment. Their surfaces were heated by the protostar, and their insides were warmed by radioactive decay. They were melting and differentiating, with heavy elements sinking to the core and lighter elements rising to the surface. This process, known as differentiation, was shaping the internal structure of these embryonic celestial bodies. But the dance wasn't over. The planetesimals continued to collide and merge, growing larger and larger. Some of them reached a critical size where their gravity was strong enough to attract even more matter, setting off a runaway growth process. This was the birth of protoplanets, the precursors to the planets we know today. Over time, these planetesimals would collide and grow, setting the stage for the birth of terrestrial planets. This was the dawn of a new era in the history of our solar system, an era marked by the formation and evolution of planets, including the one we call home, Earth. As these planetesimals collided and grew in size, a process known as accretion, the foundation for our Earth was being laid. Picture a cosmic game of marbles, with these planetesimals smashing together, sticking, and gradually growing larger over millions of years. This wasn't a gentle process, but rather a chaotic and violent one, full of fiery impacts and colossal collisions. As these building blocks continued to collide and merge, they formed larger bodies, protoplanets, that eventually became the terrestrial planets we know today: Mercury, Venus, Earth, and Mars. Earth, our home, was one of these protoplanets, and its formation was a result of countless impacts and the relentless process of accretion. This process was not without consequence. The constant bombardment generated immense heat, turning the young Earth into a hot, molten sphere. As it cooled, the heavier elements sank to the center, laying the foundation for Earth's core, while the lighter ones floated to the top, forming the crust. This accretion process resulted in a young, hot, and molten Earth, with its layers starting to differentiate. Our young Earth was not a peaceful place. It was bombarded by celestial bodies, shaping its early history. Imagine the early solar system, teeming with rogue planetesimals. These small bodies, leftovers from the formation of the planets, were on a collision course with each other and with the newly formed Earth. These celestial impacts played a significant role in shaping Earth's landscape. With each impact, the planetesimals transferred their energy and material to Earth, causing massive changes in its topography and composition. Over time, these impacts helped create the diverse terrestrial landscape we see today. But there was one impact that was unlike any other. This was the impact that led to the formation of our moon. This is where the giant impact hypothesis comes into play. According to this theory, about 4.5 billion years ago, a Mars-sized body, often referred to as Theia, collided with the young Earth. The energy from this colossal impact was so intense that it vaporized Theia and a significant part of Earth's outer layer. This vaporized material was then ejected into orbit around Earth. Over time, the debris coalesced and formed what we now know as our moon. This theory explains why the moon and Earth share many similar characteristics, including their isotopic compositions. It's also why the moon lacks iron, as it was formed mostly from the crust and mantle of the two colliding bodies, which are less rich in iron compared to the core. In the grand scheme of things, these impacts, especially the one that formed the moon, played a pivotal role in Earth's geological evolution. They influenced Earth's tilt and rotation, which in turn affects our climate and seasons. These impacts played a crucial role not only in shaping our planet but also in contributing to the development of Earth's early atmosphere and oceans. So next time you gaze up at the moon, remember, it's not just a beautiful celestial body, it's a testament to the violent, chaotic, and incredibly fascinating history of our planet. With the formation of oceans and the development of a hospitable atmosphere, the stage was set for the emergence of life. Imagine Earth, billions of years ago, a young and volatile planet beginning to stabilize. The first oceans, warmed by the young sun, were brimming with the ingredients necessary for life, a cocktail of elements and compounds that would soon interact in just the right way. Now picture this. In these early oceans, simple organic molecules started to assemble into more complex structures. These structures over time evolved into the earliest forms of life. Amino acids, the building blocks of proteins and nucleotides, the building blocks of DNA and RNA, began to form, setting in motion the extraordinary symphony of life. The Earth's formation, its oceans, its atmosphere, all contributed to this remarkable process. The story of our planet's beginning is ultimately the story of our own beginnings. Thus, from a cloud of cosmic dust, our Earth formed, setting the stage for the greatest show of all, life. Our journey through time, tracing the birth and evolution of our planet, has been nothing short of amazing. We've explored the vast molecular cloud that birthed our solar system and the gravitational forces that molded the protostar and protoplanetary disk. We've witnessed particles collide to form planetesimals, and these building blocks grow through accretion, creating our Earth. We've delved into the depths of Earth's composition, from the core to the crust. And we've seen the power of celestial impacts in shaping our world and birthing our moon. We've touched upon the development of our early atmosphere and oceans through comet and asteroid impacts, and pondered the mysterious connections between Earth's formation and the emergence of life. We hope this cosmic journey has sparked your curiosity and ignited a passion for understanding our place in the universe. So, share your thoughts, ask your questions, and let's keep the conversation going. Thank you for joining us on this cosmic journey. Don't forget to subscribe for more fascinating explorations into the mysteries of our universe. Until next time, keep looking up.